Good day everyone. In this tutorial I'll be talking about the RAM subcircuit. The RAM we know is a memory storage, and for our RAM we can see the different outputs, and the RAM, as you've seen, have only one input and only one output and several inputs. So let's discuss briefly about these different inputs. One of them is the chip select. The chip select actually enables, as you can see, it goes here. It enables the RAM to read this address. That is, when you want to read from a particular address, you need to enable the chip select to be able to read from the address, because this multiplexer blocks the address, and unless you've enabled the chip select, you can't read from any address in the RAM. So that's basically what the chip select does, and is an active low signal. That is, it works only when it's low. That's why it has a NOT gate on it. It works only when the signal is low. As you can see, it's energized. So let me turn it on, and I will turn it on so you watch. It goes off. When I turn it off, the signal comes on. So that is why it's described as an active low signal. So it only allows the RAM to read the address only when the chip select is off. Then it also comes here, feeds into these two AND gates. I'll talk about them shortly. Then again, the address comes from the CPU. That is the address of the part of the RAM we want to read. Then you have the normal reset. This reset button resets two registers and the RAM. This particular register, this register, and the RAM itself. So you can see the wiring of the reset, how it goes from here to here, then it comes down here, and then also it resets just the two registers. It doesn't reset the RAM. Yes, you shouldn't be able to reset the RAM, but once the system goes off, we know the RAM resets itself. So that is it. Then again, this particular register stores the address of where we want to communicate with, while this register temporarily stores the data we want to insert into the RAM. So we will see how shortly. Now these two signals, RAM write upper and RAM write lower. Let me check something. So the right lower and the right upper, I think I need to remove the N because it's no longer an active low signal from after I switch the signals. So these two signals enables this data to be written to either the upper or the lower. So if the RAM write up is on, it means the data will only be written to the upper part of the memory. If the RAM write low is on, that means data will be written to the lower part of the memory. If the two are on, it will be written to both sides of the memory. Now see how they work. So this OR gate means when either any of them is on, enable the memory to be written to. This is the right enable bit. So whenever you select any of them, right to the lower or right to the upper, then it opens the RAM to be written to. So any of them can open the RAM. So but if you didn't select any of them, that means you can't write to the RAM. So that's one of the things it does. Remember, this one prevents you from writing to any address. It doesn't allow the RAM to accept an address. So then again, now this security down here, so these two AND gates are used to enable the upper and lower part of this bit, and one of the legs of the two AND gates goes to the chip select enable. That means for any of the AND gates to be on, you need to enable this, or I'll say turn it off, so that the signal will come on, so that it can be fed to the two parts of the AND gate. And lastly, you need signals from each of the right, and then from the upper and from the lower, so that you'll be able to enable the lower part of the RAM and the upper part of that particular address you want to read with. So by the time you've opened it, either the upper can pass or the lower can pass through this register, from the register to the RAM, and from the RAM you access them. So let me take a sample example. Just watch. So I reset everything to 0. Then the chip select needs to be off for it to be active. Then I decide to write to address 1, or rather this address 2. You can see that that's been highlighted inside the RAM. Then let me give you a value there. You can see that at the output it didn't take the value. Reason is because the RAM write up, you've not selected whether you are writing to the up or to the low. So let me make a choice here. So I select the upper. Now you can see that only the upper have been affected using this upper value here. Until I turn the lower, that's when it will take the lower value. So let me do equally the same here. You can see the lower have likewise taken into the RAM. So this is how we use the RAM sub-circuit. If you have any question, you can ask me in the comment section. This is basically what the RAM looks like. This is a generic RAM in Logic Sim, but I already have some RAMs I've designed, but I didn't use them. Example is this one, my RAM 16. It consists of 16 D flip-flops connected together. It's actually a register that can store a 16-bit register. Actually, yeah, registers, which are also storages also. So thank you so much for watching this, and subscribe to my channel.